All right, so now let's work an example of defects in ceramics. So again, this is going to be on your quiz, and we're going to look at a slightly more complex structure, not from the unit cell at least. So here's the unit cell of corundum, which is the structure of Al2O3. And what I want you to do is just in words describe the defect structure of both a Frankel and Schottky defect, those that we just talked about in the previous module. Describe that defect structure. So again, just in words, describe as much information about the defect structure, combination of those that you have to have for this material and this structure. So do that on the quiz, pause the video, and then come back and we'll work through that together. All right, so let's go ahead and take a look at these examples. So we're looking at Frankel and Schottky in Al2O3 or corundum. And so doing this, if we start with the Frankel, again, the cation is smaller in this case, so we would expect that as the species for a Frankel because we have a vacancy of the cation coupled with an interstitial of the cation. So basically that aluminum, which is 3+ in this case, goes from its normally occupied site to an interstitial site. And so that's how we can describe a Frankel. So it's just a movement of aluminum 3+ from its spot, creating a vacancy, to an interstitial site. And you don't have to, you can kind of show if you want, but just an interstitial. You don't have to specify exactly where it goes. Just an interstitial is good enough for these exercises. So for the Frankel, this is where we have coupled vacancies. And again, it goes with the formula unit to balance the charge. So since we have Al2O3, if we remove one aluminum, that means we'd actually have to move 1.5 oxygen. So we just couple that as 2 aluminums. So that would give us +6. And then 3 oxygens, which would be -6. So basically, you can always think of it as a formula unit. 2 of these, 3 of these vacancies will give you a balance of charge inherently. So that's how we can balance it in that case. And that's how we would do this for corundum or Al2O3.